Good day everybody. The end-to-end product developed using MuleSoft Anypoint 4 with implementation of continuous integration and continuous deployment will be demoed. Use case: when pharmacist sells the drug in hospital management system, an invoice is generated. The same will be transported to SFTP location, that is Linux, and a payment voucher will be created in insurance ERP application. Simultaneously, a fund transfer occurs in insurance and hospital's bank account. Here, data is transformed, mapped, and enriched as per the individual application needs. MuleSoft Anypoint Platform will be used for deployment. Note, as there are constraints with the license cost and other factors, the following workflow is used to achieve the continuous integration and continuous deployment. Let me walk through the workflow. The web service project jar, Anypoint runtime engine, created Docker file are converted into Docker image using Docker command. The created Docker image is used for creation of Docker container. The created Docker container will communicate to the MuleSoft Anypoint platform. Note, the communication occurs between MuleSoft Anypoint platform and the application deployed in the Linux box. Now, all the three involved applications such as hospital management system, insurance ERP, and bank application are in Windows OS, which will communicate to the web service project developed in the WSL2 Ubuntu. Before proceeding to the continuous integration and continuous deployment workflow, let us validate the developed integration manually. Let me create and generate the invoice. The invoice is created. Let us review the invoice generated. This is the details of the invoice which is being generated. Let me navigate to the SFTP location. In the SFTP location, an invoice is created with the voucher number concatenated to it. This is the invoice which is created by the web service. Navigating to the ERP application and verifying the voucher details. This is the voucher details. This is the voucher number. Let us reconcile this voucher number with the PDF which is being generated. So the reconciliation is successful. The invoice is suffixed with the voucher number. This is the insurance company's bank account, and here there is a fund transfer to hospital's bank account and its details. Here is the hospital's bank account. Let me refresh. Here there is a credit for the invoice amount created. This is the overall workflow and interconnections created. Thus, the communication occurs between the application deployed in Windows OS and the web service project developed in the Linux box. This is the continuous integration and continuous deployments workflow. Let us go through the workflow. In the web service project, build.yaml is created, which will drive the continuous integration and continuous delivery. Additionally, pom.xml is updated and an update in code base is made. Code push will occur. This will push the code to the GitHub repository. Data gets updated in the repository. As continuous integration is configured, the Git actions workflow will trigger the build generation and deployment. Here, the configured any platform user access token and environment details are retrieved. In the MuleSoft Anypoint Platform, the server and applications are triggered. Finally, the initial or redeployment of application occurs. I have made changes to the code base. Let me push this, entering the code comments and committing, performing a git push. A git push was successful and the code base has been updated. Let me navigate to the actions. As this is continuously integrated, the build pipeline has been triggered. So the build pipeline, the build generation and build pipeline is successful. The deployment has started. The deployment is successful. The application jar file has been deployed to the server sandbox. Let us also confirm that this is runtime manager, and if you see, a deployment has occurred recently. As a final check, after the continuous integration and continuous deployment in MuleSoft Anypoint Platform, let us execute the end-to-end scenario and validate the same. Let us review the end-to-end scenario details in all the involved applications. Let me create and generate the invoice. The invoice generation is successful. Let us review the generated invoice. These are the details of the generated invoice. So in the SFTP location, an invoice PDF has been generated with the voucher number suffixed in it. In the ERP application, a payment voucher has been registered and it details. This is the voucher number. Let us reconcile with the PDF generated by the web service. So it is reconciling. So this is the insurance company's bank account. Let me refresh it. Here a fund transfer has occurred to the hospital's bank account. This is hospital's bank account details. Let me refresh it. Here a credit has been made from the insurance company's account to hospital's bank account. This is MuleSoft Anypoint Platform monitoring module. Let us review the performance metrics which are captured here. This is the graphical representation of Mule messages. This is average response time, and this is the errors graph. This is JVM CPU utilization, JVM heap used, JVM thread count. Let us review the inbound performance metrics. So this is inbound total request by request type. So all requests are having OK responses. This is inbound average response time graph. The response time is reducing, which means the performance is good. This is inbound average response time by HTTP endpoint. It has two inbound endpoints, and one has 164 milliseconds and another has 486 milliseconds. This is inbound min response time by the HTTP endpoints. This is max response time for the endpoints, inbound endpoints. So this is the 99th percentile graph. The response time is almost same, constant here. This is 90th percentile and this is 70th percentile. In 50th percentile, the response time is decreasing. Let us review the outbound performance metrics. So this is the outbound total request by response type. All are OK. outbound average response time. This is the outbound average response time by the endpoints. There are two endpoints which are corresponding to outbound. An average response time of one is 180 milliseconds and another is 262 milliseconds. This is the min response time of the outbound endpoints. This is the max response time of outbound endpoints. This is the total requests by the endpoints. So this is outbound 99th percentile, 90th percentile, 75th percentile and 50th percentile. In 99th percentile and 90th percentile, the response time is increasing, and until from 50 to 75 it is decreasing. All the performance are consolidated here. This is Mule messages, this is average response time, this is inbound average response time. All the performance are consolidated here. There were also errors in the performance metrics captured. These were of initial dry runs report. So these are other graphs which are generated. Let us review the JVM's performance metrics. So these are the various metrics captured for the JVM. JVM uptime, thread count, and various metrics are captured here. Let us review the infrastructure performance metrics. CPU utilization, JVM heap used, total processor, system memory, thread count. So this is the overall monitoring results which are captured by the MuleSoft Anypoint Platform. Advantages: enhanced scalability. Web services becomes more scalable. Improved security. This aids to improve security because this allows user to manage security policy across multiple platform, example Linux versus Windows. Upgraded portability. Here developer can move their applications from one cloud provider or device type to another with a minute effort. Condensed cost. Comparing it with virtual machines helps a lot in reducing infrastructure cost because they use fewer resources and have less overhead cost. Quicker error recovery. Great advantage of this is that it can detect the infrastructure failures and automatically work around them. Apart from monitoring and alerting present in the MuleSoft Anypoint Platform, external applications such as Splunk and Elastic can be integrated and plugged in. Note: the underlying stack beneath the MuleSoft Anypoint Platform are Docker and Kubernetes cluster. Thanks for your time. Thanks for watching.